space. It's a bit of a, the step is a little small, but you can see it.
Very small. So you're putting this.
But you know what happens when you put a ring in there? The ring gets a little off center, and then it sticks.
Yeah.
Because it's undercut. You see?
Yeah, very little. Yeah. And this is a little.
There's a little slop in there.
Yeah.
But that's okay. Once you have the whole assembly together, it should. Then this goes in. Now, the way I normally do that is I have something, like whiteout, like what the secretaries use, is down here.
I see this. Okay.
And the lens, if you look at it, this has, it is curved on both sides, but it's curved more on the front.
On this side, okay, yeah.
As you see the picture over there.
Yeah, this
it's a
one.
dual lens. It's a doublet.
Okay.
So you put it with the flatter side up here, and gingerly lift it up.
Oh, okay.
Till it seats against that thing. Okay. This is a soft interface. And that wasn't done too well, was it? Okay. Now you put in this one because that is a, that the Delrin shears when you put side forces on. So this one is on top of it. That's the pressure ring. Okay. And you put this one in here. Sort of spin it like this. I hold it like this and spin the whole assembly.
We can make a tool here to go around.
Because let me do a little first here. Never use any force, What I hold the spanner wrench and move the thing underneath. And hold that in place. No, you missed it. It's not there. In there. Right.
It's been a while since I've worked with it, so maybe Joe has something that he can do.
That gives it even,
You could have that on the board.
That's the way you do that.
Okay.
Actually, I just do a little bit. And
Then
what I do, I just, well, I know my fingers.
Oh, you need a. Oh, that thing is for tightening.
This thing is giving me a little trouble, but it doesn't want it. Because you should be able to change this, while it's inside. But,
Thank you, Mike.
The problem is, I don't have red ink left.
That should not do that here, but anyway, we'll just there we go. Also
This is.
this has to slide.
Okay.
If it doesn't slide right, it seats. It's okay. Because you later have to work with this when it's inside, and then you have no way to do anything to it. It's going to go.
Oh, and the pinhole is eccentric?
Right. Yes. If it's not, it's not perfect, that's okay. You realign to it anyway. Now, it's dirty. I don't like this at all.
Okay.
Just took the paint off?
The lens fits here. It goes in, but the flat side down, as it is shown here.
Oh, flat side down. Okay. Flat side.
I have this. See, you want the flat side towards the beam that has an angle, okay? And you want the curved side towards the parallel beams, because otherwise this surface has to do all the work. If you have a collimated beam and a flat side, it doesn't do any work.
So you're reversing.
So you have to reverse both of them. Yes. Because it's upside down, you're looking at this upside down.
Okay, so
The flat side has to be, alright, so now I need, yes, that's good. Okay. Now what we got to do is we got to find some glue or something to glue this in. Okay. Well, what I like about it is it's not pretty clear, does it?
It's a hard coating.
Yeah. Well, this goes in like this. See, there's a recess in it, so it doesn't touch the lens. No. there's a burr in here.
From that,
That's okay, a little bit of this is okay. Now,
we have to do this or something.
no, there's a set screw
Oh,
here.
set screw there.
That's it. That's the one. I put a little. Okay. Now.
Screw that thing, right?
Okay.
Set
Now,
screw.
that may stick out a little bit. We may need a like a little class A is a set screw to hold this, and we use a 172 by 1/8 here. That's first.
That's lens first, then?
Yeah, lens first, and then.
Second screw is a 172 what?
Which one? The one.
The screw that holds that filter into the assembly.
Oh, this one. That's the 1 by 1/8.
The one you're...
And we use a lens. Okay, now.
It not surface down the bottom.
Yes. Okay. It fits. Image. All right, let's put this. Yeah, we put these things in here. Okay. These are they are
approximately
these three
172 3/16.
yeah, they serve to align this lens
But
in the lateral
but
plane.
with this far back, with our 65-degree lens,
I'll show you in a minute why that is done.
yeah,
Yes.
Oh, Mike can take
but
that.
that'll cover
Yes.
12 inches.
Yeah, almost.
Yeah. Yeah.
The number is 172 by...
Yeah, but I want to go
I want to turn upside down. Come on. You know how you tell what's upside down or something like that?
With a fine point. So you want the reflective side out?
Well, you want to get the first surface mirror. This first surface mirror, you want it down on the globe.
Okay.
Okay. Because, right, see if you look, if you have the sharp point here, if you look from a certain angle, you can see it's not touching.
It's
it.
not meeting itself.
Oh.
Yeah. Reflective side down.
See, the one problem with this is that you lift this up somehow where I can see. You see, with a proper fixture, you just put it in and it
Go there.
has the right orientation. Okay. It's shown, you know, from the front. And if you turn around, you see, you know, like this. What it is a. It is used to split off a certain amount.
What does that called?
That's called the beam splitter comma cores.
Mm-hmm. And that goes where on the drawing now?
That goes on a part here called. Let me just. It's difficult to see. Nobody has a, and that was a lifesaver. Fixed it by making a thick one of foot. Okay. It's time for the UV treatment. Put this down on this seat. Put this down.
Just right there.
Wait a minute.
surface, I mean, no.
You glue it on the side. See, there's a very thick side surface. The way you do this is you put the stuff here, proper, somewhere close to the top. Not
on the side.
below, so it shifts it up, pushes it up.
This step.
Like this. The filter goes in here. Is to protect the laser, because if you look at the optics, you're focusing heat radiation down the laser, you're heating up the laser, and that raises its threshold fiercely. So this protects the laser, nothing else. Okay. Good. Look.
I think I saw that.
Okay, now. Okay. Down here, It's okay if it runs a little over, it's not a catastrophe. Okay, this has to be like 5.
No, inside, okay.
Bigger piece here. See, there's like there's an undercut here that looks sort of like, just like that. That's like, the dimensions are not right. This is too short and too high. And basically, you push the this is the thread of the laser. Has a threaded stem. Okay, and you push this through. Well, I can make a picture here because this is not machining issue. It has to be machined.
You machine the nut round.
I machined the nut round, and then did the slot business. I've misled you there before. Again, all right. You don't want to walk backwards again, so I walk forward. Okay. There's this thing here, and there's this flat thing here. Now, this flat thing here goes here where the feet go in here on this side. See where all these holes are? That's the feet. And the transmitter and receiver are going to be this way, and that's where this is going to be. Okay, so now I do. These are 172 by 3/8. What I do, hopefully the threads have been cut properly. If not, we have to chase them. Before I put Loctite on, I want to make sure that they go down. Otherwise, we have to chase the threads.
172.
Black Phillips, right?
Yes. Yeah, this thing's really nice. Swoosh it.
Yes.
Put Loctite on. See, I always do it first because action is. Now, I think better to remember is this thing here. It has to be on this plane, the open plane.
And 2 screws, right?
Yeah, with the 2 screws.
This screw per one.
Right. There's going to be a pot,
The mill and these are
potentiometer, that eventually measures the movement of the lens.
Oh, this plane.
We should do that. Let me. Okay, if you look through here now, you see the split image. Don't touch it there. Get it underneath. Do like this. Hold it like that. Okay. And then you rotate this thing in the front here, the knurled knob. Yes. You should see the split image. Do you see the split image?
Yeah.
Line is kinked. It's displaced from one prism to the next.
And when it's in focus?
Then it's aligned.
So like I saw something turning half and
When you turn it's like our 2 color units. Where I have this in there, I have to just transfer it over. Let me just-
Does the felt go on all sides?
No, just on the inside here, on that the side opposite where the laser comes in. That, let's say, trim this here, see? Mirror, we don't need to even go all the way down.
The picture you're making.
That's right. To know which side, see it has a stripe in the middle. That stripe has maximum reflection at the laser wavelength. And maximum transmission if possible in the visible, because you want to look through, this is an optical path in the viewer.
Yeah.
So a laser, which is already an elongated beam, and it's going to be hitting it this way, so it's like, it's confined to this thing. And now the question is, which one is up or which one is down? And in this particular, the business surface has to be down. No, sorry about it. It has to be up. I always think about this. The business surface has to be up because the beam, I'll take a minute here, comes in like this. Because the laser comes up from below, so the business surface is out. It's supposed to be outside.
What are the properties of
Well, I think it's the kind of glass they use for photo mask and stuff like that. Now we should have that lamp on.
optic to look at the reflection?
Right. At a certain angle, you see the red reflection coated is up. And let me do a little. And we're applying. Here we should not be stingy. Color on the outside. You don't want this to. Okay, now you see now what the repurpose is of this thing here, right? Of that belt. This goes in like that. The laser beam comes down. 98% gets reflected, but first of all, a little bit sneaks through. And if you had a shiny surface there or anything that would reflect, it would reflect it right back into the detector beautifully, okay? So also a little bit sneaks over the edge, so you gotta have something, you gotta have a trap. So then this is a pretty good trap. Okay, so now this has to go in like this, and it does fit. You have to line up these holes here. There we go. Now we need a little bit of right. Okay, now we use this should be funny.
Like 3D sketching.
I had a guy working for me once who was an absolute. Okay, this is good now. This is all right. See, the screws actually are underneath this belt. Okay, so now we got that. I think we should put the feet on first. Okay, let's put the feet on. This is our. Is there sound with this thing, this camera?
Yes.
Oh. All right. There's another one here. We can use, for this we can use one of the longest, one of these screws. But we don't do it now. There are 5 of these screws. Now here, see, I think he's okay. That's why you want the foot here so you can conveniently work the teeth here.
There's a special.
There's a slot in there.
So that's Loctite?
Yeah. They should have enough Loctite for this. Okay.
Oh, okay, to hold in the tape.
Now, that'll be.
So it's not easy.
Yes, that's a little easier. Not too much because you don't want the grease all over the place. We should really have like a little tray, what we call the inner. Yeah. So tilt a little more. See, there's a raise in here. See this here? There are 2 races in fact. 2 grooves here, right, all around. There's a groove here, counter groove, see, on this side. There's no counter groove for this, you see that little later why that is. Incidentally, these things are glued on and pinned on, you see this here? We have a tool here to drill it somewhere. See, this groove and the counter groove over here, there's an opening. We can get the ball through this opening into the groove. Oops. You gotta move here until I'll let you do this. To get it over the innermost groove.
This groove, right?
No, not this one here, the inner one. This one has to go
this
over
one,
that
okay.
groove.
Okay.
No, not just yet. First line it up. First line it up. If it's not lined up, it's hard to see what there it is.
We have to make some kind of spot here so that we can identify that the
Put paint
white, yes, the little white paint, so that's exact that thing.
to do that.
Yeah.
Are you trying to line all
So
over?
that's not putting the,
When you go on this side, what you're doing is you're taking the target away from
whether
the
it's a little,
so you're going to be looking at the whole of it. So then
or,
Well, there.
first you're going to
or
look at the edge, you know it's going to be 100% because that's what you focus. And you're going to move it
it's
into
there, but we need like a sharp tool.
Oh, go through that.
When you do this, there it goes.
So how many?
How many go in?
Also, sometimes he may have made the tolerance a little tight.
So you're feeding the whole ring of beads? in there?
Right.
How many are you going to put?
106. You could do that better, right? Than he made it too tight, I think, because sometimes they just slide in like nothing. They just go in.
Go in there.
All right, I'll let you do. I'm wiggling like that because it's a second raise, but they only go in here like that, and they should be. This is soft material, this is brass, and yeah, better do that. And they're brass, so they're supposed to prevent this thing from rocking. So you have a second raise to prevent it from doing this.
Oh, if it's
Yeah, sometimes they just roll in. You know what? I'm gonna put a little more here because this needs it.
so this screw you go put all the way in, or just one quarter?
You'll see in a minute. Come on. Now what I'll do, I'll tighten them
Little, okay.
all that time.
Yeah.
I think I can put down. You think that may
That
could,
make no sound at all. That will be more smooth, right?
Yeah, let's put that good grease in there. I don't know how much we need here. Okay, let's see something here.
And
So where that Teflon washer is,
I don't know how quick is your machine is.
that's where the place where the Teflon washer is.
Smile, come on.
Oh, not this. Oh, I see. Okay. Oh, but I have to put on more. Oops.
So the converter doesn't go.
172, 3/16.
Yeah.
You have the box?
That should help hold in place.
Hold the screw
Yeah,
nicely.
with the nut, yeah.
Okay. In here, the receiver. Now, we use this
Sliding.
mirror. That's the alignment, the first alignment. Okay, which has to slide in here.
That goes to infinity?
Yeah, it goes to
Okay.
infinity if this is all the way
In.
in.
Hmm.
And then we have this thing here. Tape it on so that it stays here. Okay. Tightening it now. And then what I forgot is this here.
Yeah, I gotta empty the box, okay?
This
I don't want
No, today Friday I have to leave early. Back and forth, and we can align on back and forth, and then we have to have a little mirror that we put at like 45 some down here, a little mirror. So we look at that spot, and we have to get the laser spot centered and brightest, maximum bright. We can make a drawing here.
Okay.
It's the easy way.
Isn't it? Yeah, that's good.
Because now all of them
And you have
the highest reading from the same spot.
How come? I just adjust to higher reading, so mine does look.
here, here. And you have a radical here.
Same reading.
With average.
Wood, upper. 345 and 340. But still, I mean, say some higher reading is opposite side, right? Same
Right
level.
on the edge. No, like low. Right on.
So, this is the double.
Oh, yeah.
In the A,
Mm-hmm.
just like
Yes.
That will have the line in the middle, right?
Yes, this is the stripe. Up there is stripe.
Yeah, okay.
With stripe.
Some of them are.
Now we are trying to get the Heaney
I don't
to go.
Come to the stream, right?
Right, we're going through here. Straight.
345. But this is with upper.
Now you gotta.
Let's see.
It has to go through the pinhole fully, which means the brightness. If it's goes at some angle, say here, then you are not in the center here. If it goes at, if you then move it to the center by moving this around, in other words, if it's not straight, then you're blocking the. Let me just do something to tilt it here, okay? Well, you see that it's not at the center of the target. So let's say you move this there, you can move this back and forth because this is in this. You know, this has this mount which can go back and forth.
That's a sliding one you put.
That slide, right. Now, by sliding this back and forth, let's say a beam is like this. You could bring it in the center here, but you're missing the pinhole up there, okay? So if you go through a pinhole, which is indicated by maximum brightness, and at the same time you're going through the center here, through of the reticle, you have gotten the beam straight, okay? Now, I'm drawing this in dashed now. What comes afterwards, optically, no, you have a lens like this, and then you have a lens like that, okay? So you're re-imaging the pinhole onto the detector. This is where the detector will be, in this spot here. And this way you image the pinhole on the detector. And in here you have a filter. Do you see the advantage, the point of this? Your target, or that goes in like bounces off the wall, could make it through the pinhole, but it's not going to be re-imaged in here because this cone angle here is matched to this one. So anything that is outside of the cone angle that comes from here, for instance, rays that bounce off the wall and go through here, will miss the detector.
Oh, yeah, these sections.
The target here. If you have the filter, let's say right in front of the detector or the pinhole, you have a lot of concentration of heat. You heat that filter up locally, it's glass. So this way you spread out the energy and you do not have much filter heating. Because you can get quite a lot of energy. When you're in a furnace, you have quite a lot of optical infrared energy that goes through. Now, anything beyond, let's say, 2.5 micron is blocked by this lens, by the glass optics. But, you know, if you talk about 1,000 degree kind of furnace, or centigrade, or maybe even 1200, the peak radiation is that if it's 1200 Kelvin or 1500 Kelvin, then you have 2 microns is the peak energy of the Planck curve. So you get like, at that high temperature, you get like 50% or so of the energy that comes in here gets focused on there. So it's quite a heat loss. Can't get it any further. That's it. No more.
It will go to screw well.
Let it go down here. Well, but I don't want to touch anything.
From the top it drops already.
Yeah, the drop should have done it.
Oh, flashlight here. Kevin, you have the flashlight?
Put it in the back here and let it drop without touching anything, okay? Off this thing here.
Maybe
I'll let it drop, just fall down in the back.
nephew,
To hold this temporarily, and then when that glue is hard, I'll put on either side some. I'm not afraid, because you don't want to touch it. See, epoxy is very viscous, so you know you touch it and you move it.
And you move the mirror.
You don't want to touch this thing
Right.
anymore once you have it aligned. So that's why I'm letting a drop of epoxy go in the place I can watch in the back. And then, I see your flashlight here.
Yeah.
Someone's got there. Almost up against the mirror.
So you ground it until.
I ground until I had a little more clearance there. That was it. That was the whole thing. That just dropped down. Okay, good. That's good enough. You see, all I need is a little bit that it catches a little bit. And is this other one, is that? No, that's no. Let me get a non-linting. This is a holder.
Hold up, okay.
But also is a heat sink at the same time, but it wasn't the intention.
Okay.
What did you put on now? A piece?
Yeah, this is a detector. Then on top of the detector, we put this mount. It have 2 holes on the back that matches these 2 holes.
Puts an inside star lock washer. And what we want to do is we want to connect this ground plane to make contact with the what we call the detector holder, with this aluminum body, thereby surround the detector with the ground plate. Okay. It is. Good.
But you may modify
See
it
this here?
to be included.
Oh, grounded with that.
There's
Okay,
the
screen.
ground and then I have this here. So, okay. Yes.
He's not familiar with it.
How do you switch this off?
Spreadsheet, but this is the procedure.
Put it like that. See that? There's a gap here.
Oh,
To
because
mount to this thing, so you have to grind away
cut off this thing slot.
this lip here. Okay, so it looks like this.
Same
and
surface
this.
with that thing. The
Yes,
same
yes. Short screw on the side where the prism comes close. And the 4 millimeter, 3 millimeter you use where the prism is a meter. Yeah, 3. See this here? If you have a longer screw, it's going to grind into the glass and damage the glass. So you use a 3 millimeter here and there. It just, you see, this is just makes the width of. That's why undercut everything is important. Otherwise, you start nicking the glass. But you see that in the picture. If you nick the glass anyway, you have a blemish somewhere in the picture because of folding, the way the optics folds. All right, this is done. Actually, we don't want to make it too well. This is okay.
56
No,
quarter
this is
mile.
172.
Oh, 172.
You know what? Somehow this doesn't. This
Highlight columns
and
D and
we do this.
This is a normal screw, not a metric.
This is the American style screw. This is a camera piece, therefore it's all metric. Japanese cast, a Nikon camera.
No.
But that's a very complicated prism.
Yeah.
Okay. All right, this fits. Fits very nice. This is an American.
Normal.
What is this here? Doesn't want to go through. What is this?
Now,
Okay, this is it. All right, now.
Big.
Thank you very much.
That thing don't go all the way.
72 by a quarter.
I think they're quarter. Let me just take a look.
See, where is the first drawing?
This is called, my book is over there. The holder 50-002-02
copy this.
with the lens and the filter assembled. And you
Bring
put the lens part in first. So you're looking at the filter.
value.
And you make sure that it's all the way down here.
So I just
And then-
pasted, cut and pasted.
With the set screw.
Only one side.
Yeah. Now we should use or have to. And so down here you can see the stripe. Put this in here, up here. Put this in all the way forward.
You see window audio, you should see two bottom names.
This is another tool that should be up.
Not
Looks nicer and
surface.
nicer.
So,
Huh?
Nice, it looks very nice.
This is an adjustment. You see, you need.
Is it? You don't see anything, right?
right click.
The light.
Is the final.
Where's the drawing that I?
Yeah, that's what I'm looking for.
Another. Oh, I just realized I have to also bring another tool up. I have to get one. in here. Oh, this has to be. So you adjust the lens, and that moves the focus, the focal point of this lens moves back and forth, and you line it on, and you put the detector in here. Let me hook myself up here. Also, find a handy tool is like a clamp, a surgical clamp. You know what I mean by that?
That jumper? Alex, I'm sorry.
Yeah.
Between what?
Between these two.
That's the gold lead of the detector?
Yeah. Right.
Is that for thermal?
No, that is by picking a resistor, you get the right gain. Since the laser varies so much from one to the next, all right, the power of a laser, even for the same input, you have to do something to account for that. And what we have is a voltage divider going. The signal goes into this amplifier, amplifies AC and DC. Then it goes through this capacitor here. The DC goes out through this purple wire. The AC goes through the capacitor into this amplifier. It's a times 100 amplifier, and it has a voltage divider between this and this resistor, so this and this. And by changing this voltage divider, you can adjust for different laser power. Also, when you have close-up lenses, the reflected laser power can change drastically because it's quadratically dependent on the distance of the target. So this allows you to voltage divide the signal that comes, the AC signal, which is a pulse signal, from here before you amplify it up. Okay, and that we start off by having no voltage dividing. In other words, keeping the signal as is with a short here.
Filter.
Yeah.
Then the other one you're.
Right. Here you have the picture. We have
Yeah.
a lens, a filter in one assembly, and then the other, and shown also somewhat smaller, right?
Yeah.
So you can adjust it, and then comes the, by the way, not the right dimension. This should be as wide as that.
This is the curve side got this.
Yeah, well, forget about it. He made better pictures here.
Oh, you suppose it? Okay.
It's corrected already. By the way, this has to be made as wide as that. That's another thing.
That's the part we made before. Okay.
Right. That's it. Now, you need to put. That's going to be a little difficult to put the lens in there. Normally is, and I remember it. Do it this way. Open up this thing so it can pivot. See? Alright, so one thing you have to make sure is that you don't drag the prisms, because the prisms, they stick out, okay? They're not flush. The prisms underneath this surface, if you look carefully here, you see that they stick out. You know, one corner of it sticks out, and that means if you drag it across an edge or something, you get those corners dirty.
Which comes first, the leakage test?
So what I do, now, you know, do this, I tilt this up, I put this in with the flat surface down, and there's a curved, there's a lens here.
So there's a Nikon.
Nikon, oh, it's Nikon. Okay, this way. You don't drag it across an edge. Very important.
Flat surface down.
I need more.
We have to reapply.
This is better because this is really
Oh, you know what?
the light can get into this.
We should use a longer screw here because you can't use it there because it gets into the field of view.
Leakage and current to offset.
Yeah.
The leakage
The 3/8. No, this can't be 3/16. It's longer. This is 3/8. Okay.
26 volts, 42 volts. 10 seconds.
Feels that it's a little more solid. It's supposed to be drilled deep enough to take this.
Every one of them. Never shut this one off.
See, this here, you can't do that because it would go into the field. You see, it would stick into the field of view. Because in the back, you have this opening here, this here. See, this screw thread goes through into the open space, and here is the screen. You would see the screw head in the field. This one here is completely hidden in the metal. So if I use the longer one there, because it gives you more strength, you know.
This one doesn't matter.
Right, so we do this.
The mic is going to teach you how to do it. With the manual mode, everything goes down, but it's not the computer.
Okay. This, that. Yes. So all we need to do is put
Which manuals? That would be some.
successful in there already.
Now, next morning when you come
So we
back,
gotta find
the only thing I want
one over there.
to make sure you go through cycle, then you have to polish it. You know, to give you some example, at the beginning, we had every 10 units, we have 2 or 3 failures. At the end, we had 1 failure every 20 units. Because you don't want to trust the very in advance, not getting your back. I don't want to give hundreds of these things and then finding all of them are wrong.
This one has manual auto. So
That's painful.
you come in, just put auto, turn on, and
Okay.
same button. Manual.
Those are
Down arrows.
172 by 1/8. These set screws. They're used to move the thing sideways, to move the screen.
That'll be adjusted later.
That we adjusted that later. Once we have the optical axis found with the detector,
Mm-hmm.
They're going to simplify this
then
one
we
also
look
with
for, we overlap this
We're going to be moving
with this pinhole. In other words, we fool around with this
Serial number.
until we get maximum signal. This points any which way. We don't know exactly where it aims. It aims just at the right spot. Then you adjust the screen so that it's centered on this aperture over there. And then, you know, on the aperture in this,
Recalibrate.
and then you have the viewing axis aligned
Not just the units.
to the infrared receiving axis. The last thing we do is align the laser to the rest, to this common axis.
Okay, now we're going to check it. This is to become 141. In other words, everything is practice right now. You can put it here. 10 seconds.
It's a green.
You control the switch on it.
No, this is a green. And this will go red on red.
The only thing is, I have to make sure the water is in. And it's 45.
Oh, you know what we forgot today? Let me.
Oh, the software is down full.
This is on volt DC volt.
Set up 50.
That is on.
Very good.
There's a little bit there. You know what I wonder?
Second lens.
Yeah.
Thank you.
Oh yeah, we were way off there. Okay, now I need
Put this back.
to go in from here. Oh god, I was way off.
Instead of aligning the field stop, Pete, you're moving that second lens.
And then look at this again. Okay, you got that now. Now, something is very wrong. Something is extremely wrong. You know what? Since this is a company with lots of black bodies, we gotta put this up in front of a black body tomorrow, okay? Because I don't trust that lamp. There's something. See, a lamp is not a uniform source. You get, you don't get a.
How much temperature we need minimum?
1,000 degrees.
1000 degree. This is the center piece we are adjusting with 3 screws to make in this exact center. So
Right. Well, it's not necessarily a center. The detector isn't always. It isn't exactly everything in the center. It's to match it to
match
the
the detector. Yeah.
The detector is not necessarily perfectly the center
Right.
because tolerances.
Yeah.
Okay, we got now. I sent you a sheet for a test sheet. You should print that out and work with that. So we write the numbers down, cell alignment, and we start with this voltage. Black body temperature. What is that over there? 900.
900 C, approximately.
Celsius. Okay, and then we have a voltage here of 0.404. Okay. Right now, the next thing we have to do is get to the laser. Okay.